Hello everyone, I'd like to welcome you all to this series on how to build your very own Linux distribution absolutely from scratch. And in this video, we'll download, configure, and compile Linux kernel. So without further ado, let's get started. So I'm going to create a directory with make-a-dir called Linux. This is supposed to be a working directory. So yeah, just want to cd there as well. And before we start, we need first to resolve the dependencies, essentially downloading all those packages that we need in order to actually being able to compile the Linux kernel. So in order to do that, I can say sudo apt-get and install, and then the list of packages. So we'll start with the fake root. So fake root is really handy when, let's say, we're having the root cpio.gz compressed file system. Essentially, that's the init ramfs. So when we're supposed to be unpacking that, making some changes and packing it back, that fake root is really helpful tool, although it might not be directly have any regards to the kernel, but still something that we definitely need to install to make sure that the entire project will compile. Okay, then I want to install build essential. So this is actually the most important part because you just want to have the proper tool chain so that you can actually compile it. So you have the GCC, like compile all this stuff. Okay, then ncurses dev. So when you do make menu config on either Linux kernel or BusyBox, it brings like a nice TUI with sense for text user interface, ncurses style menus, so hence the need of ncurses. Then we want the xz utils, so to make sure that we can uncompress stuff, right? libssl is self-explanatory. Then BC stands for basic calculate, so that's a sort of a programming language that allows you like to define variables, do some arithmetical operations on them, even define functions. It's really like a simple programming language, but well, I have no idea why is that needed, but yeah, for some reason it gets included when it comes to resolving the dependencies needed to be installed in order to compile the Linux kernel. Then Flex, I guess Flex is just a more sophisticated, like a newer version of Lex, which is the Lexer. Flex and Bison, Lexer and Parser, so somehow used as well. And finally, last but not least, is libelf dev. So ELF binary format is quite rare, it's quite old, but it's really fantastic. Well, for instance, if you, just to give you an idea in regards to the ELF format, so let's say you have a Go programming language, like a program written in Go programming language, and you just build the project, and as a result, it would most likely produce the ELF file. That's the statically linked one, so it doesn't have any external dependencies, even on the leaps on the glibc. It just doesn't have those. So it's really cool that you have the statically linked system. So and in particular, indeed, we are supposed to be dealing with these. With the BusyBox would be compiled, would be statically linked. So that's another thing to bear in mind. Now let's try to run this and see. Right, so obviously I already have all of these packages being installed in my system. So just clear the screen for now. And now let's download the kernel. So I can say widget and https, then cdn.org/pub/linux/kernel/version 5.x. So a few words in regards to versioning is about to be said just in a while. Bear with me. And then the kernel itself. So I'm using the one called Linux-5.10.76.tar.gz. Okay, let's download it. So now the kernel is being downloaded, which is good. So the version 5, like the latest family of versions is 6, but this one is the version of the kernel that is used within my Linux Mint Victoria, which is the latest by the time of recording this video. So it has quite a cool default configuration, which we will now talk about in details. All right, so now we have this archive here, so we need to extract it. So I can say tar minus xvf and this archive, and this creates the directory called linux 5.10.76, and it extracts all of the files from the archive right in there, right? So it takes time because it's quite huge. It takes even more to like build. But anyway, so we cd to this folder, and here we are interested in file called config, but we don't have this yet here because we didn't yet configure the system. So if you say make help, it gives you a hint on in regards to the available targets for the system, available system targets you're supposed to be building. So you see this x86 underscore 64 underscore def config. So that's the exact one we're supposed to be using as the template, and then we'll be altering it. So I can simply say make and x86 underscore 64 def config. And now I can just hit enter here, but there is a trick. I can specify the number of cores I want to use. So if I use the output of the command and proc, in my case, there's only 2 cores, so this is going to be compiled a little bit faster. So it's not compilation, it's just a matter of making makefile. But anyway, just quickly run it. Okay, so when the configuration is done, you see the configuration is written to a .config file. Now, if I have a look at this .config file with a text editor, just without slash .config like this, then we have a whole lot of settings here being either activated or deactivated. So we will now go in details through these. But generally, I want to mention that there are quite a few approaches to how one can deal with the configuration. So one of the possible opportunities or options is to just run def make menu config, which would introduce the TUI text user interface based and curses based interface, where you can manually in a menu like style select those features you want to have or do not want to have. You can also have do this via the interactive the command line style tool, where you just prompt it like, would you like this feature to be set to yes or no, and you just answer the question. But that's quite long, and you can since that's done manually, you can always make a mistake. That's not an option. Also, you can use the things like command set or using the EZ editor to embed those lines into your build script to automatically change the values within the file. And that's more a proper way of doing things, but that's still not bulletproof, because the problem is that within different kernel versions, the def config file, this one produced here, is really different. So let's say the def config for the kernel version 5.10.76 is vastly different from like the latest Linux kernel being published. So, and this would never result in the kernel that is supposed to be running on the target hardware, so it would always miss something. That's not the way to go. And probably the most bulletproof way to go is actually to have, you need to carefully create the configuration file, test it on various systems, make sure that it works and does meet all the requirements, all the needs you're having. And then, based on that configuration file, no matter the kernel version, you can calibrate the default configuration by the one that you've provided. So just enough words, and just want to show you this. So you would be able to download the configuration for the Monkey C, Monkey 2 Linux distribution. That would be linked down below the video in the description. I'll have that installed locally, so I can simply say cp, and I want to copy from home, my user folder, desktop, and Monkey C, Monkey 2 Linux, and I have a CFG folder there, and a file called kernel CFG. I want to copy this to the Linux source files, and also want to call it kernel.cfg, right? Now, I want to run the diff command. So what is the difference between the configuration provided by the def config and the one I have kernel.cfg. I want to redirect this to the file so that I would be able to show you the content of that file in a text editor. Right. So, for instance, what we have here. So the host name was like none, and I've changed the host name to monkey see, monkey do. Well, that's not essential. That doesn't make pretty much anything. What is important? I do set the NVMe support here to yes because I have the SSD drive on my laptop. If I don't set this up, I would not be capable of accessing the SSD drive on my laptop. So this feature is quite essential. Also, frame buffer VICI is equal to yes. This is also important because otherwise you may end up not seeing anything on your screen during the boot. I've disabled the penguin logo. Well, probably shouldn't, but anyway. I've changed kernel debug yes to no because to not set because it just makes results in binary kernel binary a bit smaller. And also, I've added a few features here. So reset attack mitigation gives kernel an idea that it should clean the random access memory every time it reboots. So it's quite handy, quite useful. Then disable Apple properties, well, just to make the kernel a bit smaller again, because yeah, this is not running on the Apple laptop. It's just running on the laptop running Linux, so Aspire 3 in my case, and config EFI mix. So it means that it can run like legacy BIOS or UEFI boot. So both are supported by the kernel. So these are just the differences. The rest is the same. But again, if you run this diff command with the one I've provided, like my personal configuration, the one that I've provided for the monkey see, monkey do Linux, and let's say you compare it, make the run the diff command against some whatever other different Linux kernel, this will result in having way more like differences rather than this one, because essentially the build, essentially the config that I made is built on this particular Linux 5.10.76 kernel version, and that's quite neat. By the way, that's the exact version my latest, by the time of recording this video, the latest Linux Mint Victoria is actually using, so exactly the same kernel. So although there are kernels like 6 point and whatever, Linux Mint Victoria still uses 5.10.76. So just to give an idea, so you don't always need to have the latest kernel. And again, if you're having a different kernel, just need to make sure that the configuration meets your needs and your requirements. We will walk through the entire configuration just once we replace the default configuration with the one we've just added here. So I just escape, and I just want to say remove the existing configuration. So, well, again, you might be wondering why did I do this then? Well, because apart from generating the configuration file, it also did more things. So it's quite essential to run the def config anyway. So, but anyway, I just can remove it now. And I use mv to move, or essentially to rename the file called kernel cfg, and I want to rename this to config like this. And now if we have a look at the config, so this is the newly created file, just can scroll through it. So it's quite an interesting, to be honest. So some essential things. So let's say, I want to say RTL, so Realtek vendor for Ethernet devices, because again, if it's not configured properly, you will end up not seeing the F0 Ethernet 0 interface under the ifconfig command. Okay, so just yeah, so config WLAN vector Realtek, yes. Well, although this is set to yes still, I don't quite see the wireless interface for some unknown reason. But yeah, that's not only for this particular. It's all the Linux kernel also don't see the wireless interface. It's get a little bit more complicated to configure that one. I'm not quite sure how that is done properly. But yeah, another thing before I forgot. So the values for the every configuration entry might be Y, which stands for yes. It might be N, which stands for no, and it also might be the letter M, which stands for module. So you can either have the kernel containing all the device drivers you're interested in, or alternatively, you can have some device drivers being like taken away from the kernel, and then the chunks of code being dynamically added to the kernel as the modules. So that's just the matter of the architecture. So just to give an idea. But to make things simple, and since I don't really want to build modules separately, although that's also possible, but I want the single kernel binary to contain all the device drivers I'm interested in, hence this sort of thing. So yeah, RTL cards. So this comes handy for Ethernet. Here is the list of the cards. My particular Ethernet card is neither of these. But if I had this, yeah, in that case, I should have said this. All right. So if you have, let's say you have a Realtek Ethernet card, and this is one of these. In this case, you should actually set it to make sure that it just works better. It might not work if you don't set it. It may or may not work. It's hard to say, really. So this is relevant to whatever device specific or to whatever devices. So whatever drivers. So you may want to have the you might want to set the IWL Wi-Fi or these guys or whatever. So let's say Tiny Core Linux has these guys as the modules, as the firmware. Sorry, not the modules, but as the firmware that are being downloaded from internet and then being installed. Although I'm not quite sure whether that's the matter of providing the Linux kernel modules or that works somewhat a different way. I'm not quite sure. I still need to make some research on it. But anyway, so that's the configuration. So what else important? Yeah, the frame buffer. Frame buffer. Just look for the frame buffer. So another essential thing, because when it comes to frame buffer devices, so we have this configure frame buffer command lines equals to yes, notify equals to yes, configure frame buffer equals to yes. This is one of the very essential. So you might find the device dev FB0, so that's the frame buffer. So that's sort of a virtualization of the graphics for a Linux system, simple words. And again, like other Linux kernel configurations, default configurations might not have all of this settings being set to yes. And in that case, I've tried like a whole lot of different versions of Linux kernels, and every time I've been compiling it, again, it's like up to 30 minutes. Every time I just see the blank screen on boot. So if you see a blank screen on boot, but you did make sure that it's all right with your init script. Like say, if you just can use a different kernel, frame buffer versus VICI is also very important. And the EFI is also very important because if you're running as UEFI system like I do, without this setting, just again, it would be just a blank screen. It's more tolerant for the legacy BIOS, but for the UEFI modern stuff, it's really sensitive to have this features, these sort of entries being set to yes. So configuration is really sort of a tough thing. So if you like how to debug, say you have a blank screen when you boot and you are sure that your init script works perfectly well, in that case, you can simply try to use some existing kernel. And if with the existing kernel you see something on the screen and your init script works like a charm, in that case, that means that there is something wrong with the configurations of your kernel. So you need to make sure that all the frame buffer and graphics related stuff being set up properly, or otherwise just see the blank screen. So that's just a matter of practicing. And again, if you are going to compile Linux kernel, don't think that you will just done it once and forever, and you would know, and you would not need to do this one more time. So when I had that sort of a mindset, I just ended up like whatever I've compiled on my own just didn't work. It either didn't see the hard drive, or didn't see the Ethernet, or just couldn't see a single line of code on boot. So that was quite devastating. But when I realized that I need to get used to the fact that I'm supposed to be recompile a Linux kernel like 10 times, 20 times, 100 times, no matter how many times. in that case, you're just getting calm, and every time you recompile the Linux kernel, you start understanding more about the configuration. So it's really like the trial and error approach, but it's quite efficient in terms of like you're starting to understand what it makes the difference when you compile Linux kernel many times. So I encourage you guys to compile Linux kernel many times, playing around with the configurations and see what is going to be the difference. So that being said, now we can escape from here, and now we already have the kernel being configured. And now it's time to actually make it. So I can say make and bz image, and you can probably even not say that because that's the default target. And again, you can say -j and use all the cores. But if I do this now, I just tried this previous time, and my system had, so I couldn't even end recording the video. Just everything was vanished. So I will instead just run it like this. But again, specifying all the cores is quite important, because in that case you would be able to have the compilation happening faster. So just run it, and yeah, it would now ask me a couple of questions. So I do not want the multipath NVMe support, and no hardware monitoring as well. And apart from this, it now starts compiling. If you're interested in watching the entire compilation process of the Linux kernel, have a look at the video I made recently, which is called "You Can Endlessly Watch the Fire Burns, the Water Flows, and the Linux Kernel Compiles." So if you want to watch this sort of footage for like 30 minutes long, and I would now just skip to when the kernel has already been compiled. Okay guys, so the Linux kernel has just been compiled, everything went smoothly, and I've also managed to do a hell lot of useful things, like for instance cutting the grass in the backyard during the Linux kernel was compiling. So now it's time to go for a bit of testing. But the problem is that without the root file system being available, we will not be able to successfully boot. But this, like just the pure kernel itself, it's already enough to see that the kernel actually boots. And if we run it, it would end up panicking because it will not find the root file system. But anyway, it's worth showing how the particular version of the kernel is actually supposed to be booting. So we are now within the kernel directory, and here within the folder arc. So let me list this. So arc, and the architecture is x86. Just x86 is enough. Yes. Then boot. Yes. Then boot. And here we have the, we should have the kernel, the bza image. So yeah, we have the bza image here. Great, now let's cd upwards. And here in the working directory, in the working Linux directory, I want to say mkdir, so make directory called ISO. So this is where our ISO is going to be let's say compiled. And I want to say -p, so I want to create the parent folders. So ISO boot and grub. So we will also need to include the bootloader, because otherwise it's not going to work. Right, so if I just have a look at the ISO, so just cd to the ISO, here we have the boot, cd to the boot, here we have the grub, cd to the grub, and here we have nothing. So the very first thing to add is actually the grub configuration file. And I've been making a couple of videos already showing in details how you can make one. So for now, I would just limit myself to using the ready-made grub configuration. So I just can copy this from the local folder. You can download this from the monkey Linux distribution. Well, in particular, extract this from the ISO. Just do the following. So home and cmk desktop monkey do. and config. So yeah, if you just clone the repository, this is going to be the case for you in Grub CFG, and I want to copy it here. Okay, so we have the Grub CFG now. So let me have a look. Let me show you what is in there. So just basic settings. This is basically this is the UEFI sort of a configuration file, but it also works with legacy, but it also works on QEMU. Some important things. So we're using the GFX term, and instead of set GFX mode auto, here you can say set GFX mode equals to like this, for instance, 76832, to make letters just a bit bigger if you want. But yeah, just want to keep things auto. GFX payload. So GFX mode is the resolution for the Grub. GFX payload is the resolution where the Linux kernel is booting. So keep means use the same resolution for Linux kernel booting, just exactly the same that it was for the Grub. And we want to output to the GFX terminal. Then just create a single menu entry. So this is called monkey see monkey do Linux. And just import the gzio to be able to unzip, like uncompress the kernel, petition MS-DOS, so that boot actually works. And these two are the most important things. So under the boot folder, we have the BZ image, and under the an init RD. Although, so don't be confused by init RD. We're supposed to be using the init ramfs, but for the Grub configuration, this is still called like init RD and boot CPIO GZ. So this is not going to be available just yet. So that's not a big deal. But just to make sure that we can actually boot, this should already be enough. So quit from here, and now again, like we have the Grub CFG within the Grub. And here into the boot, so here, boot, okay. Now I need to cd into the boot. So here I want to copy, so from, let's do the absolute path. So home, CMK, desktop, Linux, so that's the folder that will work in directory. Then Linux 5.10.76, then arc, then x86, then boot, and then there should be the BZ image, and I want to copy it here. Okay, so ls one more time. So we have the BZ image now being the part of the future ISO. So now I just go like here, yes, and one level up. Yeah, and here, okay, so now I can do, so in order to produce the ISO, I can simply say grub mkrescue. So that's the command. Output file, so let's call it msmd-linux, okay, and .iso, and the source is the ISO folder, like this. Okay, let's have a look. Says like everything has been done completely. Hope so. MSMD Linux. Now let's try to test this with the QEMU. So QEMU system x86_64, because we have compiled the Linux kernel for the 64-bit system. Hence we use the QEMU, the 64-bit QEMU, and just say minus. Well, I just also want to say minus no graphic, because I want to run this in this particular terminal window, and to use cursors instead of SDL to render things to screen, and then to see the CD-ROM and MSMD Linux ISO. Because this also can specify the memory to 1 gig, but for now, well, that's not really needed because we don't yet have anything polluting the random access memory. So with just the bare kernel, we cannot specify that. And if I did everything properly, it now actually should try to boot the kernel. So the bootloader is working. Well, rendering sucks a little bit. Not quite sure why is that happening, but anyway. So now we should see, okay, error. That's because it just doesn't file the root CPIO GZ because, okay, yeah, well, that's obvious. That's obvious. So, well, anyway, okay, anyway, it still tries to decompress the kernel. Yeah, cool. It's actually cool. So it will not panic because, yeah, it just doesn't find the root file system yet, but still. Yeah, panic not syncing virtual file system and unable to mount root. So this is absolutely fine. Yeah. So although under the Grub configuration we did specify the root CPU UGZ, but it wasn't available, but still it sort of boots. So just wanted to give you an idea that the kernel that we've just downloaded, configured, and built actually is capable of booting. So that's the core thought. So this is in regards for this video, and in the next one we will compile BusyBox, and when we will do that, the next step would be to provide to build the actual root file system. So we'll build a very basic root file system already in the next video. When it comes to like more sophisticated things like adding devices, like populating the dev folder, etc., like the proxies, whatever. Then it comes to setting up the networking. So I have a lot of things to do. Well, but in the next video we'll just compile the BusyBox and try to actually boot, so that there would be the rudimentary root CPU.gz, so that we can actually boot into shell, hopefully. And then, starting from there, we would be enhancing the system so that to make it a bit more usable. That's it from my side, guys. Thanks for watching, and I'll see you in the next tutorial.